So, a hollow right semicircular cone of semicircular angle alpha, where tan A is 3/4, is fixed with its axis vertical and its vertex downwards. So it means vertex downwards means point of the cone aiming downwards. So look, I'll just finish off this cone for 1 second. No, that won't. Put this here. So it was going, just meets down the bottom there. So you can see that's the bottom of the cone there. Now, the inner surface of the cone is rough. Once you see the word rough, you're already thinking friction equals mu r. The minute you see it, write it down. With the coefficient of friction being 1/2. The cone rotates about an axis in uniform angular velocity. So you're talking that within the cone, this thing here is just going on the inside of it. It's constantly circling around like this, then back around the other side, and everything's cool. Okay, with uniform angular velocity, so omega equals 7. So we've already got the centripetal formula picked for us, mr omega squared. Okay, it's already picked for us, but giving us that information there. Okay, particle mass m is placed on the inside surface and rotates in the cone at a vertical height of h above the vertex. Calculate the normal reaction of the particle with the inside surface and the height h above the vertex if the particle is about to slide down and if it's about to slide up. Now, can anybody tell me the difference between sliding down and sliding up?
Sliding down, acceleration is lower, and sliding up, acceleration is higher.
Well, it can be an acceleration in either direction. It doesn't necessarily mean higher or lower. So, example, accelerating up it by 1 or accelerating down it by 1. The magnitude is the same, but it's either going down or up. So, not necessarily that. Now, what I will tell you is when you have friction, guys, when you have friction and you're about to move, friction always opposes your motion, doesn't it? So the direction of friction, if you're on your way down, friction is acting upwards. If you're on your way upwards, friction is going to be acting downwards. When you're on the verge of going up or the verge of going down, friction will act in the opposite direction to the direction you're just about to go in. Okay? So, what we're going to do here is, what was it, number 10. Okay, so I'm just going to resolve some forces. So, let's start off with R. R here is perpendicular to the surface. Okay, so what we have here is R. Now, we can see that it sort of makes a reasonably nice triangle there, doesn't it? A 90-degree triangle for R. So, what we can do is like this. R, yeah. So I want to resolve R. I want to resolve it parallel and perpendicular. Is that right? Parallel and perpendicular. So we got a R here. Now, if I draw it across like this, what happens now? If I draw it across like that, and will tell me what angle this is? 90. This one here? 90 minus alpha. And this part here, because it's 90 degrees itself, it must be alpha. So what I've basically solved there is that that's alpha. And that's going to be, do we know what A is yet? Oh, we do. So let's work on that. Tan alpha being 3/4. Therefore, sine alpha being, thank you, and cos alpha being 4/5. So we have all that information there. So this one is R cos alpha. This one here is R sine alpha. We will convert that shortly. We're going to convert that into 4/5R going to the right and 3/5R going up. Is that alright? Okay, now, next thing. The particle is about to slide down. That means we're going to have the presence of a frictional force acting again. It's on the surface. Now, the friction acts along the surface parallel to that surface. So, friction force is going up this way. The friction force, so if I just draw along this line, I'm just going to construct it here. So, see the way the friction force acts along this line here. And this line, so if I just take the two of these out of the way here, And remember, friction acts along the surface. Might make just that wee bit shorter. So what we have here is a friction force triangle. Okay? So what we can say is that's alpha there. The friction force was a mu r, is it? Mu r, otherwise known as a half r. A half r is the perpendicular acting in this direction here. Are we happy with that? Now that that's done, what is this part here? A half r cos alpha, a half r sine alpha. That makes sense? Half r cos alpha, a half r sine alpha. Now, what you're basically doing there is you're halving 3/5. So sine alpha being 3/5. Cos alpha being 4/5. So what we can have here is 2/5r going up and 3/10r going to the left. So 2/5r and then following that by 3/10r to the left, and that going up. Everybody happy enough with that? Okay, let's start with what do we always do? Now remember, this whole category is horizontal circle. Okay, so it's motion in a horizontal circle. What do we always do for motion in a horizontal question? Horizontal circle, what? Okay, every single time for this type of question, force F up equals F down. Okay, so what's going down and what's going up? Remember our mg, isn't it, going down as well? Mg, perfect. Okay, so what's going up, guys? 2/5r. Anything else? What about the green triangle? Okay, what about the green triangle? Green triangle, anybody? 3/5r going up that way as well. And then forces down? Huh? Mg going down. So R equals mg. First equation there. No bother. Question 2. Your centripetal force equals mr omega squared. What is going inwards in this direction here to cause it to spin? 4/5r and minus 3/10r. Well done. 4/5r minus 3/10r equals m. Do we know the radius? Just tell me the radius. No. So m r7 squared. Okay. So let's sort this out here. So we're going to find out is that what's 4/5 r minus 3/10 r? It's going to be 5/10, isn't it? 8/10 minus 3/10 is 5/10, so a half r equals 49 mr. Look at both equations. Any idea what to do next? Yeah, why not? A half mg equals 49 mr. M cancels, doesn't it? And then what's that going to be? It's going to be g/98, isn't it? 2 times 49, 98 equals r. R is going to equal 1/10. We'll find it there. R equals 1/10 of a meter. Now, it also asks us to find the reaction force R. We already found what R is, didn't we? R equals mg. We don't know what m is, and then we know that the radius is 1/10 meters. Okay, not 1/10 times mass, but 1/10 times meters. Okay. Now we are asked for the height as well, though, aren't we? We're asked for this height here. The height. So this value here. Any idea how to get that? So, if you will, that's R. We know that R is 1/10. We know that's A, and we know that's H. Tan alpha equals 1/10 divided by opposite over adjacent, 1/10 over H. What is tan alpha? It says in start question. 3/4, thank you very much. Okay, so let's cross multiply this. What way will we do this? Okay, I'm going to do that as 1 over 10H. Okay, so let's change that to 1 over 10H. And then once I've done that, cross multiply to get 30H equals 4. H equals 4 over 30. H equals 2 over 15 meters. Everybody happy with that? Now guys, let's keep a note of them. We're just going to keep a note of this at the start in this question, okay? R equals 1/10, H equals 2 over 15. We're going to compare with slide down versus slide up. Is everybody alright with that? Slide down versus slide up. Now, great thing about slide down and slide up questions is most of our work is already done. So I'm just going to rub out these again, and I'm just going to reuse a lot of the information. So, now, question was, you're now on your way up. What happens to mu r now? Mu r, guys? You're now about to travel up the cone, the inside of the cone. So what happens to the frictional force? Starts opposing you. So it starts coming down this way here. So all what we got to do from last time is reverse the direction. Everybody see what I did there? Our old friction triangle, because it's a half r, which is mu times r, we reverse its direction. So now it's going to be acting in the opposite direction. The r from before still stays in the same direction, so that's no bother there. Then we go down, and we start off with F up versus F down. So what's F up versus F down, guys? F up, anybody? Green or blue triangle, anything going up? 3 over 5 r going up. Anything going down? mg 2 over 5 r. Now, bring over the 2/5 over the other side. 1/5 r equals mg. R equals 5 mg. Is that alright? 5 mg. Now, next part, centripetal acceleration, okay? So once again, it's still 7, okay? But it says one of them's on the way up, the other one's on the way down, okay? Now, what can you say about FC? It's the arrows that are going into the right. So what's going into the right? Your 3 over 10 r going into the right, and what else? My 4 over 5 r from the green triangle, and my 3 over 10 from the blue triangle. So 3 over 10 r plus 4 over 5 r. Okay, add them together and we get 11 over 10 r equals 49 r. Replace r with 5 mg. 11 over 10 times 5 mg equals 49 r. M's cancel. I'm going to get 55. 5 times 11. I'm going to bring the 49 down to multiply by the 10. 55 over 490. G equals r. Can somebody break that down for me? Is it anybody any ideas? 1.1. Thank you. R equals 1.1 meters. Now, what you notice about it if it's on its way up? Has the radius increased since last time? Last time we were radiusing, we were lower, and we were radiusing around here, and we're on our way down. This time, we're at a much wider radius, we're at 1/10 of a meter when sliding on the way down. Now sliding on the way up, we're at 1.1 meters, so we're higher up and we're about to go a bit further. Our radius is getting bigger. Okay? It's the difference between slide down and slide up. So we're obviously thinking, by that logic, the h value is also going to have to be bigger, because the smaller radiuses fit down here while the larger radiuses fit up there. So we're assuming our h value is going to have to be bigger as well. This will always be the case, by the way. Slide up will be a bigger radius and a higher height than sliding down. This has come up in the leaving cert. Okay? So what we're going to do next is the same thing as last time. Tan A equals 1.1 meters over h. Instead of having 1/10, we're now going to have 1.1. Cross multiply the 3/4. 3/4 equals 1.1 over h. H therefore equals 4 times 1.1 divided by 3. Anybody 4 times 1.1 divided by 3? 22 over 12? Or 22 over 15?
Yeah, that was 1.466.
Cool.